So hello everyone. Good morning, good afternoon. And first of all, thank you again for having us. It's always great to come to UKNOF, even remotely. I'm Jose from Meta, also formerly known as Facebook. And today, along with Elena, we are presenting our perspective on the evolution of the network engineer role. Next slide, please. If we go back into the past, specifically when I started my career as a network engineer, one of the many questions I had was around what was the core knowledge needed to be successful? What was needed to be able to do most of the projects that would come my way? What was essentially fundamental versus just something that was nice to have? And although I don't know if I ever looked as happy as the person on this slide, I ended up developing this knowledge with experience and the available resources I had at the time. Next slide, please. And if we oversimplify, it looked a bit like this. There were some critical intersections between these three domains, protocols, topologies, and how they would normally be used on the internet or on the particular use cases I had to use them for. Next slide, please. And depending on the type of role or depending on the type of project, these other three skills were also pretty fundamental. The concepts of power, space, cooling, different redundancy modes at different layers, and what the hardware could and could not do. Next slide, please. So, oversimplifying again, those cover most of what a typical engineer needs to know to be effective. But what's the difference when we are operating at scale? What's different in an environment such as Meta? To describe this better, I always like to call out on some fun myths, and I have a few, but just for the sake of time and the length of this presentation, I will only cover one of them with a few examples to illustrate the point. Next slide, please. And the first one, and the one I'm going to cover today, is essentially this myth that big networks have fixed everything. And I would love for this to be true, but it's not. Next slide. I would love that essentially this is how I looked every day, but the reality is a little bit different. And if you ask me, more interesting. Next slide. So if we look at this graph, which comes from a book humbly called How to Change the World, this graph shows an adoption curve. If we look at it from left to right, most environments such as ours typically are doing projects in one of the first three sections, the initiators, innovators, or early adopters. The reasons for this are varied, but they come down to the fact that when you have thousands of anything, any optimization becomes really meaningful. And new technology enables kind of new possibilities, which we are always evaluating as they present opportunities to shift some of the trade-offs that we have historically made when building the network ecosystem. And some of those shifts have pretty meaningful and pretty deep impacts in one of the valuables that we always consider. Next slide, please. One of the few consequences of this is the fact that the network keeps changing and it rarely looks as a monolith. We have a varied ecosystem that has many permutations of network devices and network operating systems as those fulfill, a particular business need for the different spaces that they operate on. And I know this sounds somewhat abstract, so I'm going to talk about a few examples. Next slide. So keeping in mind this diverse network ecosystem that I was describing, let's discuss how do we get information out of devices. This is, I would say, normal and pretty vital. And this data ends up feeding most of our automation, and even like the rare case when we have to do kind of manual troubleshooting or some form of manual analysis. So depending on what network OS you're running, these are some of the different ways that you can interact with it, right? You have some of the classics like SNMP or TL1 for everybody that has optical platforms. And you have some of the more modern options such as Drift or gRPC or whatever your favorite vendors call streaming telemetry these days. But the fact of the matter is that this presents a non-trivial challenge for the teams operating these fleets. There needs to be a comprehensive and modular framework that allows, extensibility, control, and a support for a multitude of ways of interacting with the devices. And interesting enough, keep in mind that we are only talking about read operations. We're only talking about extracting information out of the devices. Next slide, please. And of course, we want to do this without having to essentially screen scrape with regex all the things. Next slide. The same challenge is present when we think about another common operation in the lifecycle of any platform, such as upgrades. Similar to data collection from before, different operating systems will have different ways of doing upgrades with significant constraints attached to that process. Those constraints can range from how do you preload new code to the complexities involved with removing traffic from the device and ensuring it is healthy before restoring it. And this is without taking into consideration that some upgrades will not only be kind of like the software load, but like it will also touch firmware components that have like specific orders of operations, or some of those operations take a really long time. Next slide, please. And my last example is a bit more difficult with a use case for probing software to detect broken devices. This would be the systems that use some capability in that platform or in that topology design to probe if a device is performing correctly with synthetic traffic. The complexities of hardware data forwarding and control plane policing, just to call out a few, make building and maintaining these solutions pretty challenging, especially if you're trying to develop these capabilities in a universal fashion, which is usually what you're trying to do. And with that, I hand off to Elena to discuss how we are bridging some of these gaps with our engineers. Next slide, please.
Thank you, Jose. Okay, so I'm going to really delve deep into what happens or what we have seen so far when we have engineers joining teams at Meta and they have to deal with some of the challenges that Jose was mentioning. So next slide, please. So this is how those gaps start to manifest. Then we can talk about some ideas to bridge the gaps. So the first gap that we saw, or we see usually, is that software development is not usually part of the core component of the day-to-day life of let's say super traditional network engineer. So how is the gap manifested here? Next slide, please. Then the way that you can see it is like they struggle with writing code that is reliable, but also a solution that can be deployed at scale. So next slide. The other one is more about the incomplete knowledge of maybe fundamentals. So sometimes you might know about one protocol, but maybe there are some gaps of knowledge there. And the way this is manifested, next slide, please, is the part that we have seen in terms of implementing those fundamentals when they are, when you have to propose some solution at scale. So that's when you start looking at, okay, there are some gaps here. Maybe the protocol that they were working on a small network, now that gap is reflected when they have to design for like, thousands or millions of users. Next slide, please. The other gap is interesting because it's about monitoring. So in the traditional, let's say, environment, maybe there's a lot of manual monitoring, manual troubleshooting. The fleet of devices maybe is very small, so that's okay and normal. It's not terribly, it's not bad. But the gap here is that the way to solve problems could be or tends to be something more manual, because it might be faster just to try to automate a script if you only have a small fleet. So next slide, please. The opportunity here is like actually is a missed opportunity to kind of introduce some sort of a standardization, the way we gather, the telemetric or the data from devices or from different parts of the network. And that's one of the first kind of gaps that we see. But then the other gap could be more, okay, how do you go and automate? Now that you have standardized, how do you automate all this? So that part of kind of like a day-to-day mindset that you have or you have to have in big networks just because of the scale, that's not necessarily present on the day-to-day work of a traditional role. And that's one of the points that we have identified. So next slide, please. So here are some ideas that we also tell people when they really want to pursue the goal of, okay, I really want to work at scale. And so bearing in mind those three gaps that we are mentioning, the ideas will be the following. Next slide. So for the first one is to try and make automation part of your kind of day-to-day role in some way or form. So getting familiar also with unit testing, integration testing, things that, you know, maybe when the scale is not that big, you are okay by fixing things on your own and manually fixing that. But when you have to deploy code like reliably across a huge fleet, having some tests, it's very, very important. Next slide, please. The other one is to feel or to get comfortable with some programming language so that, you know, but really try to implement that and use it on a day-to-day basis as well. And understanding what are the use cases per language. So maybe Python might be a good one to start, but maybe you need something like Go or Rust, depending on the service that you're developing. So trying to understand what are the pros and cons for a specific language, for a specific job or I'll say like outcome. So next slide, please. Another is really try to understand one, let's say, get your favorite protocol in depth and refresh the fundamentals as well, so that when it comes to, you know, even like interview process and things like that, you have a better understanding on how to apply this to solve for a massive scale. And for example, or you can look at this as what are the limits of a protocol? How does it fail? What happens when it fails? Also, how would it work in a real world if you have to support, you know, millions of people and so on. And next slide, please. Here are some really good books that we tend to recommend. I mean, we are not sponsoring them by any way, or they don't sponsor us by any way, but there are just a few good books. For example, Clean Code, How to Measure Anything, really that one is a very interesting one to get this mindset of, you know, when people say, oh, this is very hard to measure, cannot be measured, that book really gives you an interesting perspective. Then Think Python, An Introduction to Software Design, and then Network Programmability and Automation. So those 4 books are really good if you are thinking of, okay, how can I evolve my role and what resources can I start reading or getting familiarized with? Again, these are not the only books that are in the world, but they're very useful if you are looking at continuing that path. Next slide, please. Now, I wanted to talk about how we are approaching this problem of, you know, trying to get you know, talent, but also trying to help people grow into this evolution of, okay, I work manually, I do my configurations manually, to a world in which that wouldn't be possible just because of the scale. So how are we trying to look at this problem? And the way we're doing it is by kind of creating a program that can help people define their careers, but also teach them all of these skills. Next slide. And this is how we call it, the Rotational Network Engineering Program. So this is the one that we have developed at Meta. Next slide, please. And the idea is that we boost the career progression. So we give engineers enough time to, you know, get used to with our tools and our, you know, the way we work at scale. But the idea is that as soon as they join, they have a platform to grow. So next slide, please. So we not just help them, but also we find people that have this talent or knowledge. They know about software engineering, but they're interested in the network, but they don't know exactly how to, you know, get into scale and work at scale. So that's kind of one of our looks, but also we look at people that are, let's say, network engineers who are kind of like very interested in solving problems with software and at scale. But again, they don't know how to enter that world. Again, those are kind of the 2 pool of people that we really try to help bring in and also grow. And next slide, please. And the way we do it is that we give them some time to work on broad tasks. So they learn about different domains and topologies and so on. And then they go deep into a domain with a project. And next slide, please. And then we also focus on not just the technical side of things, but also what other skills they have to learn. So for example, working cross-functionally with partners, understanding how to communicate with other teams, you know, all of the skills, including like persuasion, discussions, and how to be effectively, or how to work effectively as an engineer. Next slide, please. Finally, we also give them some support with mentors, and also with, you know, kind of like other former engineers that also went to their program. So this is the way we are looking at how can we get people that are not that familiar with the scale, and at the same time they're developing their skills, and get them to a point that, okay, now they can join a team, I don't know, let's say in the backbone, and they feel like able to contribute, and, you know, continue developing some, you know, features and also solutions. So yeah, so that would be it. Next slide, please. Thank you very much. I will leave some time for questions. Yeah, but thanks.
Thank you, Elena and Jose. If there are any questions in the room, please do come up. Otherwise, if you've got questions you'd like to either ask anonymously or you're watching via webcast, please do type them in the Mattermost channel. There is also a survey question that will be popped up in the Mattermost channel if you can choose one of the options to rate the talk.
Hey, hi, Jose and Elena. Thanks for the presentation. I'm Hari. I'm from Benox. I mean, we all know probably there were two important dates in Facebook's history this year. One was the renaming of Meta, but the other one was the infamous outage. I just wanted your perspective as a network engineer. What were the learnings, probably from the outage, and was that a motivation for this presentation?
You wanna take this, Elena, or should I?
I mean, I can answer the part of the presentation if this was a motivation, and the answer is no. I mean, the outage is not a motivation for the presentation. We have been, I mean, the rotational program and the evolution of the engineer and the gaps that we have observed have been there since a long time. And this is more us trying to, okay, what can we do to bridge the gap and help people? So on that regards, the presentation was already there before of the outage. Do you want to take the first part of the question, Jose?
Yeah, so thank you for the question. Yeah, definitely that event wasn't great. And I think it's interesting because you know, we made a blog post that describes a little bit what happened, which essentially, you know, something that was kind of supposed to go you know, to a very limited number of devices on the backbone, basically went everywhere, and, you know, caused kind of everything that came after. So we definitely are, you know, hard at work on some of the, you know, well, we already completed most of the immediate follow-ups for that. But, you know, it's always like we have this, you know, we have this incident management programs, right? You know, we have this blameless culture that we had since a really long time. And we basically go through the same process with every incident, including this one. And, you know, we always try to extract the maximum value and the maximum learnings, and, you know, obviously adjust accordingly. And that's what we're doing. So, you know, we've done a lot of the immediate short-term kind of follow-ups, and, you know, are now kind of doing roadmaps and, you know, working on longer-term projects to cover some of these gaps. That, you know, interestingly enough, some of the things we mentioned in the presentation are part of this, right? And, you know, they're part of any sort of fundamental development for systems, right? Which is like, well, how do you ensure that, you know, you can validate all your different assumptions, and especially when you have kind of an ecosystem that's formed not only about like this, you know, multiple diversity of you know, devices and operating systems, but also kind of like on top of it, you have a layer of software systems that are, you know, interdependent with each other, and that you, you know, are able to effectively manage that complexity. So yeah, it's ongoing work. Reliability never ends, right? It's similar to security. It's an ongoing, ever-present thing that you need to keep in mind and, you know, act accordingly.
Cool, thank you.
Do we have any other questions for either Elena or Jose, or both of them? None in the room either. Okay. I'd like to thank you both for a fascinating talk. Really enjoyed that. Thank you.
Thank you very much.